Hello everyone, I'm on with another project and it involves wireless communication, and what I'm using is one of these. Let's see if we can get it in focus. Right, so this thing is the transmitter. What's that? Yeah. So there, its name goes as, where are we? There we go. FS. Oh, I'm gonna give me a minute. Friggy. Right. Yeah. So where was it? Yeah, this thing. Right. So we've got this thing. Let's turn it so you can read it. How's that? There we go. Bad lighting. I wonder if I turn that light off. It is sunny outside. Anyways, yeah, there you can see it there. Look, I'll get my hand. There we go. FS1000A. FS1000A. Right. So yeah. Well, first thing you may notice is this doesn't have a coil across these two connections here. This one. Some have a coil. I've got one somewhere. One moment. Oh yeah, I think I've got it plugged in. Right. Yeah. Can you see this one? It has a coil, a little coil here, 3 windings, and the big coil. So they're both exactly the same. Both modules are the same. Just give me a, let's put that back. Got it set up. Right. Yeah, this one. Both modules are the same. The only difference is, right, is this coil or condenser? No, choke. Yeah. So coil, choke, whatever you want to call it. What they've done is replaced it on the other side with this. Let me just get my hand, because it's small. Hang on, I'm pointing to the right one. Right, yes, this one here. Can you? So this is where, see that hole there, and that hole there. That's where the coil used to go. But what they've done is they've stuck this surface mount device, which is the actual coil. Believe it or not. Let me get my magnifying glass. Tell you what. Yeah. Right. Just let me set that up. There we go. Let's see if I can keep my hand still. Right. Get it in focus. Right. Yeah. So I'm looking at this little thing down here on the thing. So if we look at that, that is this thing here. That is actually a coil. It's a surface mounted coil. They must have some layers where the copper goes round and round inside. But anyway, that's the coil. So if you, depending which one you have, it either has this on the back or it has the big coil on the front through these two holes. Yeah. So right. So I just wanted to point that out. Okay, what this video is about is I got a batch of 5 of these transmitters, and they were all short. Hang on. So I've got my meter here. Let's just put it onto continuity. There we go. And what we'll do, I'll just check. Yeah, there we go. Okay. It's a bit slow to display on the screen. It's connected by Bluetooth, but I don't know if you can hear the beep. So if I if I put my probes across, so this is this. Hang on, where's my pointer? Yeah. So this first one here is ground. This is VCC, and this is data in, basically. So if we put our meters across these two pins, it shouldn't read short, it should be open, because that's the ground and this is VCC. So let's just put the meter on, and I don't know if you can see or hear it, but it's short, and they're all short, so basically they're all useless, can't use them. But I have thought to myself, let me just get this. Yes, so this is the circuit diagram for the transmitter. It's pretty simple really. And so what I've got is, we've got VCC here, pin 3, although on the actual thing it's actually these two are the these two are the other way around. But anyways, we've got VCC and we've got ground. So ground. Now ground is only connected through this transistor, so if this transistor is not on, then we shouldn't get a short, because there's no way that we can get VCC all the way round down to ground here. I thought it was this transistor here. Now I ordered some more, but I haven't got them yet, but it's not that, because I was reading short across here, which I would be doing anyway, because it's the same as going to ground. And then I realised, looking at this circuit, it can't be any of these two that are causing the short. It must be somewhere else, and the only place I cannot see is underneath this crystal here. Well, it says 9.92. Anyways, yeah. So I thought, I wonder, because when you look at these, they're tight down to the PCB. There's no room between the crystal and the PCB. They should be standing off. Where is it? Here we go. So if we look at this, I'll tell you what, I'll bring my microscope back. Where's that? Yeah, here it is. So if we bring our microscope back and I look underneath, we can see that the crystal is flat, really flat down on the PCB. This is bad. It should have a standoff. It should not be connected so close to the PCB. Because what happens is, when you solder these legs underneath, where are we? Yeah, there, you can see the 3 pins for the, when you solder those legs, that solder that goes through there, it blobs out on the other side as well. So you can see you've got like a blob of solder there. Well, there'll be an exact copy of that blob on the other side of the PCB. And if you have this crystal flat down, that blob is going to touch the case and short it out, and that's what happened. I'll show you show you 2 that I've taken out. So here's one, and here's another one. So if we look at them, let's see if I can get a steady hand. Can you see? Let's just turn that around. Right. Yeah. Let me get my hand. This one is ground. This is the case. So this doesn't matter, even though there's a big blob on it. You can see that this one is okay. It's got insulation around it. It's not done. But this one's got a big blob of solder on it. It's shorted across to ground here. And that's why they don't work. If we take a look at the other one, you can see, well, that's the ground one, and then this one here, another big blob. It's shorted from the pin across to the case. It's not clear what it should look like. Turn that around. Well, even that one there, can you see that that has got half a blob across and it's shorting to the ground here? So basically what these pins aren't being connected to the crystal inside, they're connected straight to the case. So basically what you have to do is remove the crystal and clean these pins up. So that's what I'm going to do. So what I'm going to do is show you how I remove these, because the case is quite holds quite a hefty amount of heat, so it takes a bit of getting off. You don't need a sucker or anything. I've found, well, to get them out, I find they just drop out if you put the right amount of heat in. So let me just set that up. Yeah, right. Let's see if I can do this on camera, so you can see. Basically everything's in where I want to be, so let's give it a go. So you can see with me Oscilloscope camera that you can see the 3 pins of the oh, where's my hand? You can see the 3 pins of the crystal. This one is the ground one, so that's going to take the most heat, is that, to get out, whereas these are the 2 crystal ones. But even so, even though they're not connected to ground, they are actually connected to ground because there's too much solder on, and they're actually going to. So we need to get everything really hot. And you can see down here, these are the 3 pins there. So I'm going to give it a go. What I tend to do is try and get my soldering iron in between all 3 pins. Oh, turn it on. I move that slowly, it goes to sleep. So anyway, so plenty of solder on there. So what we want to do is we want enough solder so that we can reach all 3 pins. And then what I do is, once I've got all 3 pins, is this has a little button on it, and I can just up the voltage, let's up the heat, and then it just drops out. Well, I hope you saw that. I'm just going to pause it while I clean things up. Oh, I thought I'd show you also. Right, so the crystals dropped out of them 3 holes. Hang on, let me just point to them. So these 3 holes down here and up here, so 3 holes there. But you see they're full of solder. We had quite a bit of solder on there, so they'll be full. And what I do is I just use one of these. Where are we? Yeah, one of these suction things. You know, push it in and click, let go. There we go. One of them. Just click it down and then pop, up it goes. So yeah. So, but what I don't go from the top. Right. If there's room on the PCB, I don't go to the top and then stick the sucker on. What I'll do is I'll put the heat underneath. So if I get my soldering iron, don't know if I can get this on camera right. If you get it underneath, you can see that this one, you can see it heated up. The trick to this, to sucking all the solder off, is getting enough heat in there to melt all the solder. If all the solder's not melted, then it's not going to come out. So the idea is, you can see the solder all melting and running down. Because the soldering iron is underneath, the solder runs down to the soldering iron, and then you can just suck out the bit on the hole. And there we go. Did that show up? Yeah, hopefully. And then I'll just do the other 2. And just bounced around a bit there. Is that still in shot? Hang on, I've got the wrong glasses on. Right, there, yeah, so you can see the other 2 still. So I'll just move my soldering iron underneath. Just set me a sucker. turned on? Like I say, anything wrong with this solder. It goes to sleep because I don't move. Right, I don't know if you can see that on the camera. I'm looking at it, but I can see it all melting and going soft and runny. So then I know that it's all ready to suck. And off it comes. Let's do the last hole. Look, it's still on camera, it's bouncing about a bit. But yeah, with my soldering iron underneath, you can see the solder move and warm up. I don't know if I've got this. Seems to be on camera. I'm not sure. Oh, there we go. And there we go. And you see the excesses run off on the soldering iron. Yeah, so I thought I'd just show you how I just cleaned the holes out. Give me a moment. Right, I've got 3 more to fix. So the next step is to clean up the pins on here. Now this is what I find. Well, it's basically the same rule. There's 3 rules. Well, 2 rules. Flux and heat, really. So flux is to get it clean, and heat to get it to flow. So that's what it is, clean and flowing. So you don't want too much heat because you can actually burn the solder. It will sort of get that hot, it will oxidize. Right. Yeah. So I'll just show. I'll get one out into my little thingy-jiggy and see if I can set it up to show you how I do that as well. Right, I've got this one here held with 1 pin, and so I can get to the other 2 pins. Although I don't really need to get, all I need, this pin here is actually the ground, so it doesn't matter that it's actually connecting to the ground, because it is ground. You can see that this one is okay, that one's got okay, but I can't give it a better angle because I want gravity to do some work as well. So I've got it at an angle so that some gravity is going to let the solder flow. The trick here is to use lots of flux, so I'm just going to try and put some flux on. No doubt it's going to move out of the way. Right, it's gone off camera now. Let me just try and set that up again. Right, you can sort of see it better now. So this is this one is okay. This one isn't, and this one's the ground. You can tell which one's the ground. It's got this big dish here where the pin's clamped into the actual metal. But this one, you can see that the solder is from the pin and it also touching the ground, and we want to get all that solder off this ground around this edge here. And you can see down here I've got it at a slight angle. So because I want some gravity to go, I want the solder all to flow onto my soldering iron and not this metal bit. What's going to happen is I am going to end up soldering this case because it's going to get really warm, and so the case is going to get soldered, but that doesn't matter as long as we clear all the solder off around the pin. And this is a bit of flux here, you can see, so let's just hope everything flows as it should. Let's clean the tip. Yeah, for this you want nothing on your tip really, you just want enough solder to get the heat to transfer from your soldering tip to the solder on the thing. But you want as little solder as you can on the soldering iron, because you want all the solder from here to go onto the actual soldering iron. So I'm just leaving it in place for a while so it gets all up to temperature, and then hopefully when I drag it down, all the solder is going to drag off. pin. I don't have enough angle on it. Right, I'm going to have to tilt it a bit more. I tried, I couldn't tilt it enough to get it on camera, so, but you can see what's happening. Let me just pause the camera. Right, yeah. So this pin, this is the pin that I'm doing here. It's actually pointing down. So if you look here, down at the actual thing, that pin is pointing down. So I'm trying to get gravity for this solder to follow the pin to the end of the pin. So you're trying to get gravity to grab this solder and actually follow my soldering iron down to the end here. So let me try again. I mean, if I had some wick, yeah, I'd probably do it. Yeah, so if anybody wants to comment, use wick, you can go and buy me some. Right. So that's, I don't know if it showed up on camera, but can you actually see now there that all the solder followed my soldering iron? And you can see the insulation here now, and it's cleared all the solder away from the actual body. What I'll do is I'll just set it up so you can actually, I'll show you it with my microscope so you can see what's actually happened. There we go, there's a view from the end. Actually, let me just turn that because it looks like it's still, the other way. Just moved it out a shot. Right, yeah. It is actually, yeah, there we go. You can see that it's actually clear all the way around. Let me move that back. It looked better when it was further back because it goes all dark. But yes, you can see this is the ground, so this doesn't matter. We just need enough solder off it for it to go through the hole again. You can see all this solder around there. It looks deeper than it is, but it doesn't matter because we're going to stand this off the PCB, so it doesn't really matter too much about that. You just get as much of it off as you can, and you can see this one's okay. I'm just going to do the other two now. Be right back. Right, yep, there's the, right, I don't know if I think that's the one I did, but there's another one. So that's now clear. And there's the other one. Oh, that was, yeah, that had two pins where the solder had gone through. But now you can see that it's separated, and you can see the insulation. I think it's a glass or resin insulation. But anyways, right. Right, so I've made I've 3D printed these little standoffs so the pins can go through. So I just thought I'd show you a close up. You know, don't have to be absolutely, crucially, absolutely perfect. It just needs something to stand them off. I reckon about 1mm standoff will be okay. So let me just set this up. Oh, right, so here we have a board, we have we have a crystal, and we have a standoff. Our standoff goes on our crystal, so I'm an inch shot. Up to the right, so got that is, and I have two pairs of glasses, one to look at the screen and one to look at what I'm doing. Right, so we've got the standoff on the crystal, so that's going to hold it off about 1mm, maybe a little bit more, and then we just stick that into them holes. So right, oh, we're slightly out, right, so let's see if we get that right. So basically, so what I've got now is my crystal with a 1mm or a bit more. The pins still come through, and when we solder them now, the blob of solder on the far side, the bit that we can't see, will be held away from the can by this plastic standoff, and so it shouldn't short. So I'm going to just solder all them together. Oh, 9 shot. Right. Yeah. Oh, let's see if we can brighten it up. There we go. Same rule applies. Soldering anything with more than one leg or pin or whatever, just do one first. There we go. And then just give it a good looking over, make sure that it's positioned down we want it. I just want to put a bit more pressure on that, so I'll just hold it. I think the solder's holding it up. Don't know if you can see there. I'll tell you what, I'll bring a magnifying glass and I'll show you where the solder is. It doesn't really matter, but there's plenty of pins through, so let's just finish that off. Just do the other two. There we go. All three back together. I'll just get my microscope, and we can have a closer look, and I'll show you where the bit of solder that I had on the board made not much difference. Basically it makes it stand off more really, but it's not an issue. So yeah, what I like to do is have a close look. There we can see now that stood off, and you can see where the bit of solder was. It's not much, but basically all it does, it makes it stand off, and the solder were from the leg of the solder. Now that will be on between the board and the plastic, not actually onto the not actually on the case. Hang on, I'm trying to zoom in. Yeah, right. Yeah, so that's what we've got now. Is it's got a standoff. You should be able to buy these standoffs. There's a lot of components that have pre-made standoffs, and I'm surprised that these don't actually come with standoffs, and they've actually should have used them. But that's the reason for them, is so when you actually solder them together on a PCB, that the flux that flows through the hole in the PCB doesn't pool on the other side and touch the metal and make a short. So I mean, you can just see, can you see the pins, the pin headers? That's what that shape is there. Look, you can see that shape of the pin headers, and that's to allow the solder to pool around the pin in that area. That's why they aren't completely flat on the underside. And obviously now you know which way up the pin headers go. Okay, so yeah, we're done there. Right, what I want to do now is just briefly go over the other thing, so give me a moment. Right, so what I've done is I've set a transmitter and a receiver up, and I've written this little bit of a code to go on the Arduino Nano. Basically all this does is it goes through a loop, and it turns a pin on for a time, and then it turns the pin off for a time. But what I've done is I've made it so it happens at a set frequency. At the moment I've got it at 5 Hertz. So if we look at our oscilloscope, we should have 5 Hertz here. Well, thereabouts. Oh no, that's the blue. That right. So if I had it on the yellow, it would be 5 Hertz. You can see it's 5 Hertz when this is working right. The blue is the receiver, and my yellow is the transmitter. So the yellow is this code here. Basically, it's turning it on for it. But what I'm doing is I'm altering the period at which it's on and off, so that I can find the best amount of time on, basically, for the receiver to pick up, if you get what my meaning is. Anyway, because if you look at this oscilloscope, let's just make this bigger. Zoom. There we go. Let's move that across there, just so I can get to the buttons. So what we're doing is I'm turning on for a short period, and then I'm looking at how well the signal is received by the receiver. And if you look at the receiving, you can see that there is an issue. Obviously when it's fully on, there's an issue. It doesn't stay fully on, and when it's fully off, it's not quite right. Right, now what I'm doing here, so we can see here that we're about 40% is good. 30 and 40 is a right good percentage for the signal. And what I can do is we can alter the frequency in my code. So if we go to my code, what I can do is we can actually increase this hertz to 10, which I'm going to do in a moment, but I just want to explain something. Right, so this is with hang on, let's see if I can get me thing in picture. Where are we? We don't need that code anymore, so I'll get rid of that. Right, so the transmitter I'm using at the moment, so you can see the signal at the moment, which is with this transmitter. Oops, dropped it. Can we see it? There we go. So you can see that this one, oh, hang about, I've got the trigger on trigger is on this probe. Just let me stick it back on. I need my glasses. Right, stick that probe on there. Right, so got my trigger working again now. So you can see that this is the transmitter, and this one, if you look, you can see this has got the coil on. What I've done is I've removed the hang on, just forget the trigger for a moment. What I've done is I've removed, where are we? There. Where's the coil? Oh, right, there. Yeah. So you can see that I've removed this SMD inductor. I've removed that and replaced it with an actual coil. So I've actually replaced it with a copper coil that has 3 turns, and I've made it roughly the same diameter as this one. So yeah, so this signal that we're seeing is with an actual coil. This is an experiment I've done. So let me just stick my oscilloscope back onto the transmitter so we can get some readings. So that's with this one, and if we look, what I need you to see is that let's let this run a few cycles. Right, can you see there's an overlap? Right, so you get an overlap there. Can you see that happening? We can see that the on and off state of the receiver. I reckon that at 49, so below 50, I'd sort of say 50% duty is a good signal. So what I wanted to do is to actually is compare this signal with one with the ceramic SMD inductor on, and see if we still get that overlap there, because this length here, this length should be matching this, and this should be matching this. So this downstate should, right, like it is there, that's how it should be. And what should happen is this should always be the same width as that. But as we go above 50% duty, you can see that the receiver can't. I think this might be something to do with the op amp on the receiver, and I think it might be using that. I don't know. I don't know the name. You know, where it takes a value and then it's either on or off. So anything below that value it's off, and anything above a value it's on, and that's what's happening with the receiver. So as long as it's above a certain thing it's on, and as long as it's below a certain thing it's off, and that's why we're getting. So it always tries to keep a 50% duty on the receiver signal. I don't know if I explained that right or not, but I know it's in my head. And anyway, so what I'm going to do is I'm going to change the transmitter for one with the ceramic inductor. There we go, I'm back. Anyway, let me just move this a minute. Right, so this one is, there we go. So this one doesn't have the copper coil on. This one, let me just try and turn it over. You've got short cables. This one actually has the ceramic inductor on the back here. So I've left this ceramic one on. Both boards are exactly the same, except one has the ceramic on and one has the coil on. So there's no difference, except, let me just, well, actually there is no difference. So let me just bring back the signal for this one. We've still got the same overlap, but that overlap is, I believe, due to the receiver. I'll show you the receiver later on and try and re-explain it. I don't know, but yes. So I've just lost my probe. Hold on. Right, probe's back on. Right, yes. So there's our signal again. Shit, I've just lost the probe again. My bench is a mess, and I've lost big glasses. Oh dear. Right. Probe back on. Where's that probe? Right, probe's back on. There we go. Yes, so there's no difference between the ceramic inductor and the coil inductor. We still get the same transmitted signal. It's picking up okay. So as I say, I reckon around the 40 to 50% duty cycle is the best signal there. So what I will do is, if we look at my code, where are we? what I'm going to do in my code, I'm going to stop it adjusting, and I'm actually going to set the time on and off at say 45% duty cycle, because what I want to show you is, let's just go to the receiver. Yeah, go to the receiver. Right, so there's the transmitter. Right, let me just stick that out of the way. Yeah, so we've got a receiver which looks like that, and you can let's just try and get a bit focus on there. So there we go. But you can see it's got like an adjustable inductor on the middle there. It's an inductor with well, it looks like a brass core to me, but whether it's copper or metal or whatever it is, anyway, you can screw it in and out, and that actually tunes into the wavelength of one of your if one of these are slightly out. I wouldn't suggest adjusting one of these. I would not suggest adjusting that unless you've got an oscilloscope. So if you haven't got an oscilloscope, don't touch it. It'll be close to where it should be. Okay, but there's no issue with this. Oh, and let me just tell you that this doesn't have the big resistor on. Can you see this resistor? Doesn't have that resistor on. And I think how they've got rid of that. Well, I don't know whether they've got a surface mount one, but that big, well, it looks like a big resistor on some of them, but it isn't. I think it's another inductor, and I think what they've done is found another surface mount inductor to go on the front. I haven't really checked the circuit, but that's my opinion. It works anyway, so I've got a working one. So let me just set things up again. Yeah, right, as I say, for this bit you need an oscilloscope. So you can see that this one has got a little adjustable inductor, and what I've done is, well, we've got our ground, we've got our VCC, well, it's 5 volts I'm putting in, and then I've got my oscilloscope attached to the output, and that's this blue. The blue is the output from this receiver, and what I've done is I have altered my code. So what I've done is down here, so I commented all this out here, and then just wrote another one here, and I've made the percentage 45. The reason it's a little below 50% is because the actual well, anyway, I'll just get a picture of the receiver. Here we go. This is a picture of the receiver. Let's just zoom in. So there it is, but you can see this one's actually sealed. And you can see the other inductor here. This isn't a big resistor. This is an inductor, and I think what they've done is they've replaced this one like they did with the transmitter. They've replaced it with an on-board surface mount device, so it'll look like another little chip. It'll look like a chip very similar to the one on the transmitter I showed you, which will be like a little tiny ceramic thing. And so what we have here, we have the receiver, we've got the antenna coming in, antenna, again, right. Anyway, the signal comes in, it gets so demodulated, and it goes through our LM358N. This is an op amp, and basically we've got the feedback, and I think what it's doing is, if the signal is below 50% of the voltage, the VCC, it will read a 0, and if it's above 50% of the voltage, it will read. Well, it gives you a 50% duty cycle. I don't know how it actually works, but I think that's what this op amp is doing. Is actually giving you a true 50-50. I think if we zoom in on there, this is slightly offset to what this is. These will be 50-50, but this is like 45, 55, 55, 45, if you know what I mean. So you can see the duties changing on the blue one there, between 49 and 44, 42, 36. Anyways, it's doing its bit. But the reason why I've got this up is, so let's get that over there, and we can get this down here. Let's get it up over there. What I've got is where are we? Yeah. I like to stick things in there, so let's see what happens when I turn that. Let's do some adjusting. See what happens to the signal. I'm just trying to do this blind. Oh, hang on. That doesn't look good, does it? Right, let's try it this way. Swap hands. Right, does that look better? Let me see if I can get that in there. Right, we're in there. So, we're in shot. Let's just do a little bit of turning. Whoa, look at that. It's gone tits up. And I've only turned it about a quarter of a turn. So let's turn it back. And now we can see the signals coming back, and now we get a clear signal. And then if I keep going, well, we've gone tits up again. So yeah, so if you take a position from where it's sort of just coming in, and then you can take a position from where it's just going out, and then sort of bring it back halfway between, and I reckon you're good. That's if you want to do a bit of fine tuning, and we're done there. So yeah, I'm happy with that. That's all I wanted to show you. Hang on, what have I done? Oh, I think I had my hand on it. Just hold on a minute. Yeah, I had my finger behind it. Just remember, when you're touching it, that you act like a capacitor. So really, I should be using a plastic screwdriver as well. Right, just yeah. Like I say, I should be using a ceramic or plastic screwdriver on that, and I don't want to be actually touching the board, because if you stick your hand behind the pins, you see, like that, you act as a capacitor yourself, and you'll end up getting a false reading, and you'll be actually tuning it to your fingers. Anyways, I hope that was of some help to somebody somewhere with these wireless devices, so that you're aware that it doesn't need it. I tell you what, let me just pause it and see if I can find that ceramic inductor. Yeah, right. So if we look at the one with this inductor on here, this big green thing with the bands on, and you've got this inductor here, the 3 coils here. So I reckon they are these 2 coils, inductors. One's 1.5 turns, and the other is the 2 microhenries. So I reckon they've changed this 1.5 turns one into a, which this one here, which will be this one. You can see we've got a capacitor there, but if we look on the actual thing, I've got one down here. So I put one down, and I've shown the where are we? Where's me thing? There we go. Yes. So yeah. Where are we? I reckon it's, well, it could be either that one there, or it could be that one there. And where's my friggin' hand? Yeah, so it could either be that one there, or it's hard to tell these days because these you only know what they are when they come in the packet. But it could be this here as well. It's this white one. This could be the inductor, or it could be this one here. Either way, but I think what they've done is they've replaced this a big green thing here with one of these things. So if it hasn't got that big green thing, don't worry about it. It's not missing or broken. You can tell it's not missing because if we turn this over, you can see that where that big inductor goes, there's actually no holes. So you can see that there's actually no hole in this where it used to be. So if your board looks like that, then that's okay. Right, I think I'm about done there, because now, like I say, with my code transmitted on the transmitter, what I'm getting is this is me Arduino sending a pulse every. Oh, I'll tell you what we can do is also I can increase the frequency. Let me just show you. I've got that at well, it's supposed to be at 5 hertz, but I don't know why we're getting it's saying 10. It might be because we're getting the actual modulation of the signal, and we shouldn't. This should have gone through the op amp, I think. I don't know. Yeah, so what I can do, just to finish off, where are we? Where's my I must have closed it. One moment. No idea what I did there. I totally lost this for some reason. Right, yeah, let's just change it to 10 hertz. So I'll save that. Where's my Arduino? Let's upload that and we will see what it does. Still compiling. Oh, there we go, uploading. There we go. Right, yeah, so yeah, so we're good at 10 hertz as well. Let's see what we're like at 20 hertz. So I save that. Where's my Arduino? Let's upload that. Make sure it compile and upload. Done. Yeah, so we're okay at 20 hertz as well. I wonder how high we can go. I might try putting a capacitor into that, you know, output and see. So, so at 20 hertz we're receiving 20 hertz. So let's try 40, shall we? Let me just, yeah, get me Arduino there. Let's try 40 Hertz. Just so I can see when it's compiled. It's uploading. Yep, there we go. Alright, not so good. So I reckon, yeah, I reckon 20 Hertz is a bit bad for it. So let's just sort of 20 is alright. Well, let's try 30 then. So we know 20 is alright. So let's just upload that. Yeah, that output's not good at 40 Hertz. Although it's picking up 40 Hertz, I don't know. It might be that I just. Let's just zoom in a bit. Well, yeah, it's sort of there, but it's a pretty shit signal. Yeah, let's go back down to 10 Hertz. Save that. And upload that. I mean, it's picking it up. I don't know. Maybe I need to set my oscilloscope at something else. I don't know, but well, yeah, it is there. So let's zoom out a bit. You get it. Well, looks all right to me. Although I think if it catches half a wave, I don't know. It's beyond me. Is this? I tell you, radio signals is beyond me. But I only know so much. Well, I hope somebody found this interesting, especially if they've got some bad ones of these. And I hope I've explained why that some of these don't work. And if you get a short across them two pins, then you know what to do. You need to remove the crystal. And you need to sort of remove the solder from the back of the crystal, because if you've got a short across, it's these two pins. If you've got a short across the VCC and it's these two. Hang on, it's that one and that one. If you've got a short across them two, then you've got a short across the ground and VCC. Then you've got a short at the back of the crystal, and you need to clean the crystal up at the back of solder, resolder it in, and put a standoff there. You don't have to print one out like me. Anything will do in there. Anything just to hold it. If you just hold the crystal away from the PCB, that's all you need to do. I've just gone OTT with the printed part. But if you stick half a matchstick in there just to keep it away from the PCB, it will do. That's all you need to do. You just need to stop the solder. When you solder these on, you just need to stop the solder from flowing through onto the back of the crystal, so it doesn't do a short. That's all it is, and you'll find that they work again. So if you've got a bad one of them, that's what you need to do. Okie doke. I'll catch you later, guys.